Hello students, welcome to this session. In this session, we are going to discuss about how to parse a ambiguous grammar in LR parsers. So, the objective of this session is we are going to introduce the ambiguous grammars and the parsing process of ambiguous grammars in the LR parsers. So, depend on the ambiguity of the grammars, they are divided into two types. That one the ambiguous, second one is the unambiguous. So, now the question, what is a ambiguous grammar and what is a unambiguous grammar, and what are the problems with ambiguous grammar? For a given grammar, if I want to derive the string id plus id plus id, if there are more than one parse tree or more than one leftmost derivation tree or more than one rightmost derivation tree, such grammar is known as ambiguous grammar. Let us say my grammar is e tends to e plus e or id. I want to generate the string id plus id plus id. So, let us start with the start symbol capital E and e tends to e plus e. Then again I am expanding this e as e tends to e plus e. Now, I am using this production id e tends to id as id and id and id. So, this is one parse tree what I am generating from the given grammar for the string id plus id plus id. At the same time, I can also generate the string as e tends to some e plus e and e tends to e plus e, and using the symbols or production as id, id, id. So, here also I am going to generate the string id plus id plus id. That means, I generated the required string id plus id in two ways. So, I can say that this is a ambiguous grammar. So, for a given grammar, if we can generate more than one parse tree, then it is known as the ambiguous grammar. So, what is the problem with the ambiguous grammar? If the grammar is ambiguous, while the time of parsing, the parser is going to generate the parse tree. So, if the grammar is e plus e tends to id, and if the string I want to generate is id plus id plus id, at the time of parsing, it generates these two parse trees. This is one parse tree, this is the second parse tree. Now, the question to the parser, which parse tree it has to follow? This is the great question to the parser. So, the parser may stuck at this point of time. So, we have to convert the ambiguous grammar to unambiguous grammar. Come to the here we are going to discuss about what is the difference between ambiguous and unambiguous. As we discussed, no parser can accept the ambiguous grammar except the operator precedence parser. All the parser must need the unambiguous grammar to process. So, here we are going to discuss what is the difference between ambiguous and unambiguous. Come to the first one, ambiguous grammars are simple to understand, where unambiguous are not so simple as compared to ambiguous. Why? Because if I am writing simply a production tends to e plus e or e star e or e minus e or id. Let us say this is my grammar. So, definitely this is a ambiguous grammar. If I want to go to convert into unambiguous, here you may find 1, 2, 3, 4 productions are there. In the unambiguous grammar, it must be greater than or equal to 4 productions. So, this is very simple to understand, where unambiguous grammar is not so simple to understand. Come to the second one. In ambiguous grammar, which consists the less number of productions. While converting the ambiguous to unambiguous, it may consist greater than or equal to the number of productions than ambiguous grammar. Here we used the grammar e tends to e plus e or id. This is definitely a ambiguous grammar. So, now I want to convert this grammar into unambiguous as e tends to some e plus t, t tends to id. So, this is the unambiguous grammar for this given grammar. So you may ask it out, sir, here also two productions are only there, here also two productions, then how can you say the ambiguous grammar consists of less number of productions? But here you can find this E tends to E plus T is suffering from left recursion. So we have to remove the left recursion. So removal of left recursion may leads into two more productions. So these total number of productions must greater than the ambiguous grammar productions. Okay. If a grammar is expression grammar, so the grammar may be the ambiguous type. We can convert this ambiguous grammar into unambiguous depend upon the precedence and associativity of the operators. Let us say if it is E plus E star E. So you may find here the two operators plus and multiplication. Among the plus and multiplication of the most precedence. So we have to evaluate the E star E first, then we are going to evaluate the E plus E. That means first we have to give the precedence for the multiplication operator, then to the plus operator. But here there is no precedence or associativity. So evaluate the plus expression first, then we will go for the multiplication. But in the unambiguous grammar, the associativity and precedence are fixed one. Okay. While parsing this ambiguous grammar on the LR parsers, definitely the number of conflicts are more. So what are the two types of conflicts? SR conflict and RR conflict. SR means shift reduce conflict, RR means reduce conflict. So the number of conflicts are more in the ambiguous grammars when compared with the unambiguous grammars. In unambiguous grammars, the number of conflicts are less. Okay. So the parsing of unambiguous grammars are very easy compared to the ambiguous grammars. What are the uses of ambiguous grammars? Because ambiguous grammars are more natural and which are not much complex. Okay. So which are more natural, very easy to understand. And in ambiguous grammars which consist of very less number of productions and which may eliminate the unnecessary reductions. Okay. So here there is an example where E tends to E plus E, E star E and E and ID. So which is a ambiguous grammar. And now I am going to convert this ambiguous grammar to unambiguous grammar. So here you may find the total number of productions are increased when we compare with the ambiguous grammars. Now there is a question whether we parse the ambiguous grammars on LR parsers. Yes or no? Yes, we can parse the ambiguous grammars also. But more probably we are taking the unambiguous grammars in parsing process. But we can also use the ambiguous grammars. But the problem is, as we already discussed, if you are using the ambiguous grammars, the conflicts are more. Okay. So we can resolve this ambiguous nature of the grammar by disambiguate the grammar. Then finally again we are getting the unambiguous grammars. That means if the input may be ambiguous grammar, but we are going to unambiguate it, then finally again it is the unambiguous grammar, then it is parsed on the LR parsers. So here we are going to discuss how to convert the ambiguous grammar to unambiguous grammar. Let us say this is my grammar. So S tends to xy and xxy, x tends to x or capital X small x and capital Y tends to small I. Here my string is xxy. I want to going to generate the string. So S tends to, so simply small x, capital Y and capital Y tends to small y. So here the string is x, x, y. It is generated very clearly. Now come to the next one. S tends to capital X and capital Y. Where capital X tends to, we can write capital X and small x, and capital X tends to small x and capital Y tends to small y. So this is another parse tree. So it is also going to generate the same string x, x, y. So, this grammar is generating the x, x, y string in two different ways. That means in two different parse trees. So, we can say that this grammar is ambiguous. So, now we have to convert this grammar into unambiguous. This is the unambiguous grammar what we got from this particular ambiguous grammar. The conversion of the ambiguous grammars to unambiguous grammars also may depend upon the precedence or associativity of the operators. So, here we are going to discuss how to convert the grammar to ambiguous grammar to unambiguous grammar. So, here in the given grammar it consists of E tends to E plus C, E star E, E or ID, and depend upon the associativity or precedence we converted this into unambiguous. So, now the question, how the precedence and associativity takes place. Come to this grammar which consists of actually 4 productions, and along with the augmented production E tends to E dash tends to dot E, now this is 5 productions. Now the question, how associativity and precedence takes place. Let us say E tends to, let us say 2 plus 3 into 4. Let us say this is my expression. Now the question, which operator is going to evaluate first, which consists of the 2 operators plus and some multiplication. This is the first operator, this is the second operator. So, we must give the precedence to the multiplication. So, we have to evaluate the multiplication first, then we are going to evaluate the plus. So, solution is 14. Now, there is some more occurrence as 2 plus 3 plus 4. So, this is my new expression. Now, here in the both the cases the operator is the plus only. So, now the question, which operator we have to evaluate first. So, according to the associativity rules we have to follow the left to right associativity for plus, multiplication, division and minus. So, 2 plus 3 equal to 5 plus 4 equal to 9. So, if there are same operators are there, we have to follow the associativity. If there are different operators are there, we have to go for the precedence of the operators. So, in the given grammar which consists of 4 productions, we have to apply the closer and go to operations to construct the LR0 canonical item set. So, here we applied the go to operation, and when there is a final item, there we have to apply the reduce operation. You can find there is a final item in the given state. Okay. So, how to find the final item? If for a expression E tends to some T dot, if the dot symbol is on the extreme right of any production, then we can say that it is a final item. So, here you can see there is a final item. So, we have to place the reduce operation in the parse table, and for the go to operation on depend upon the terminal symbol, we have to write the shift operation in the action part. So, for the given grammar, from the given LR0 canonical item set what we constructed, we are drawing this parse table. So, you can find a SR conflict in the state of 7 and 8. Okay. In the state number 7 and 8, there are SR conflicts. So, the given grammar is ambiguous grammar. So, definitely it generates the SR conflict or RR conflict. So, this grammar is ambiguous grammar. So, definitely it is going to generate the shift and reduce conflicts. So, we have to convert this into unambiguous, so the conflicts may be erased. So, now come to the I7 state, what we shown in the parse table. So, because of this particular production, we have to write the reduce operation, but here there are 2 more shift operation depend upon plus and star, which indicates we have to write the shift operation in the parse table. So, for I7 state, this is the LR0 parser. So, we have to write all the reduce operation in the entire row. So, we have to write the reduce operations. Then come to the shift operation or go to operation in the place of plus and star. we have to write the shift operation also. So, which leads to the SR conflict. The same thing is occurred in the I8 state. Why? Because this is a final item. So, I have to place the reduce operations and there is a go to operation on plus and star. So, definitely I have to write the shift operations on that. So, again here also in the I8 state also we are going to generate the SR conflict. The grammar is ambiguous. So, in some states like I7 and I8 it is going to generate the SR conflicts. In the I7 and I8 state which are generating the SR conflict as shown below. So, now our task is we have to convert the grammar into unambiguous, then these conflicts may be deleted or we can overcome from the particular conflicts. So, how to overcome from the conflicts? If the grammar is a expression grammar, so what is the expression grammar? If the grammar consists of some operators like E tends to E plus E or E star E like that, that means which consists some expressions, then we can convert the grammar into unambiguous depend upon the precedence and associativity rules. So, come to the first one. If there is a SR conflict in the parse table, so resolve the conflict by favoring the shift action over the reduce operations. If there is a RR conflict, favor the first reduce operation when you compare with the second reduce operation, and the same thing is applied by the YAC, okay, which is a parser generator to overcome the various conflicts. As we discussed in the I7 state there is a final item. So, because of this final item we have to write the reduce operation and there are two go to operation depend upon plus and star. So, definitely we have to write the shift operation. Now, come to here from I0 on capital I1 on plus I4 and on capital I7. So, this is the I7 state. Now, when the current token is placed, how to find the current token? If the input expression is ID plus some ID. So, if the lookahead is pointing to plus, so that now the current token is place. So, we have to apply the shift operation when plus is right associative and we are going to apply the reduce operation when plus is left associative. So, we will end the associativity rules and the precedence rules in the operator precedence parser. The same things are we are going to apply here only. Next, if the current token is star, we are going to apply the shift operation when where star has the highest precedence than plus, and we are going to apply the reduce operation when plus has higher precedence than star. Now, the question, how can we decide plus or star at the highest precedence? Suppose in an unambiguous grammar, if it is like E tends to E star E or E plus E. So, in this grammar definitely plus has the highest precedence and star at the lowest precedence. That means the deeper level productions at the highest precedence and the upper layer productions at the lower precedence. Okay. So, it seems to be ambiguous grammar, but we are talking about the unambiguous grammars. So, now come to the I8 state also, there is a possibility of SR conflict because here there is a reduce operation and here there are two more shift operation depend upon plus and star. So, definitely it leads to SR conflict. So, now our task is we have to convert these ambiguous grammar into unambiguous depend upon the precedence and associativity. As shown, from I0 on capital it is I1, on star is I5, on capital is I8. So, now the state is I8 and we are, if the current token is star as shown in the last slide, ID plus or ID star, ID plus ID. Let us say this is my token, then we have to apply the shift operation when star is right associative. So, now the question, when we get this right associative and left associative? Suppose if it is like this, that means though both the operators are multiplication only, here operator 1 and operator 2 both are multiplication, at that time we are moving for the associativity. And come to the second one, when current token is plus, that means if it is like ID plus ID plus ID. So, this is ID multiplication, ID plus ID. So, if the current token is plus, so plus at the highest precedence then star, and then we are applying the shift operation, and we are going to apply the reduce operation when star has highest precedence than the plus. Okay. Here you can see we compared both the parse tables. So, this is the parse table before we are converting the grammar into unambiguous, or before we are applying the precedence or associativity rules. Here you can clearly observe the SR conflicts in I7 and I8 states. But after applying the precedence or associativity rules, we get the, or we resolve the SR conflicts, and we get the reduce operation or shift operation. This is possible because of the applying of precedence and associativity rules for the given ambiguous grammars. In this session, we learned about what is a ambiguous grammars are, and what are the difference between ambiguous and unambiguous grammar, and how to convert the ambiguous to unambiguous grammar. So, no one parser can accept the ambiguous grammars except the operator precedence parser. If we want to process the ambiguous grammar on a parser, definitely we have to convert the ambiguous to unambiguous. Okay. Thank you.